equals my opposite. And then how do I write that out? How would I put that in my calculator? Well, theta would equal sine inverse, right? Because I want to find the angle. Bracket 4.5 divided by 4.8. And bracket. And what do you get when you do that?
17.457.
What'd you get?
That's what I came up with, -17.
I get 70.
Well, you do the sine, or,
Inverse sine.
yeah, inverse sine. 4.5. Well, you have a minus there, that's what I did. You have a minus there, not divided.
Oh, jeez, that's why. Got my dots.
That's why I did it.
There's a divide, that's a divide sign. Okay. So they said to the nearest degree, that would round off to, I'll write it out like this. To what?
70.
70. Okay. So now I know this is 70 degrees here. The only problem is I don't know another angle, so I can't subtract to find that. I don't have a side angle pair, so I can't use the law of sines. I can't just go and find that angle. I'm going to have to find the side and then find that angle. Because I just don't have enough information to find that angle. But once I find the side, if I know three sides, I can find any angle, right? Using law of cosines. Or, again, then I would have a right triangle and I could use a trig ratio. So I need to know this side. I don't have to know it for the question, but I need to find it in order to find this angle. So a lot of these have more steps to it.
But can't you do the same thing, like instead of like 4.5 divided by 12? Oh, never mind, that's the whole thing now.
Yeah, it's not. It's the whole thing. It's not just this piece. Yeah. I could find this side and subtract and get that. That is another way to do it. There's more than one way to usually do these problems. But we'll do it. I just want to use law of cosine so we get some practice with it. We'll just do it that way for now. So I was going to write out kind of our process here. I'm going to write that. So you use law of cosines. Which we have a squared equals. So if I label my triangle with A being the side that I want to find, I can just put A here. That makes this angle A. And the BC, it doesn't matter where I put them. Let's say I do that. So now I can just plug in the numbers and find the answer. Let's see. So we'll put that in. It's just a little more accurate. And what do we get for A? Well, A squared. What do I got to do next?
Second function.
What am I doing though? What's the name of what I'm doing?
Your square rooting.
Square root, yeah.
Square rooting it.
So we square root it. And that's just a short way of doing that, right? Just putting the answer in.
A equals 11.3.
Yeah, I went to 3 decimal places, but. Okay, so now I know this equals that. Now, there's 2 ways I can get this angle. I use law of cosines, because I got all 3 sides now of this bigger triangle here, right? And just making sure I'm finding angle B when I use law of cosines. Or I also have this right triangle right here, where I know all 3 sides. I can just, or I don't know all 3 sides. I know these 2 sides, sorry. So, I personally think trig ratio is a lot simpler than the cosine formula. So I would have a tendency to use that one, but it wouldn't be wrong to use the cosine formula as well. Now, when you look here, in this right triangle here, we have a right triangle here, right? There's my right corner. What is A in this case? What's this? Is it opposite, hypotenuse, adjacent?
Hypotenuse.
Yes. Okay, and when you're looking from here, so here's my eyeball, what is this side? I want to know this angle. What is this? It's opposite. Same as it was on this side. So it's opposite again. I'm going to write that in blue. So we can use sine again. So my opposite over my hypotenuse, and then find the answer. So how do I put that in the calculator? I would do lambda equals sine -1, 4.5 divided by 0.267. And what do you get when you do that? And they wanted us to round to the nearest degree, so that would be 24. And then you just need to write a statement out. Okay. We'll look at this now. So they took some measurements of a totem pole. Well, not of the totem pole, but of the shadow and angle, elevation and all that to try and figure out the height of the totem pole. And that's what they want us to figure out. So, we need to look at how we can do that. So you kind of have two triangles. You have a right triangle here, right? And you have not a right triangle right here. Can you see that? And eventually we want to find this. We don't know this side, but we know this on the non-right triangle, right? But we don't know this, right? So we can't just, it'd be nice if it was just the right triangle and then we can easily find the height, but we don't know that. There was a hill.
90 degrees minus 5 degrees.
Yeah, so we can get that in there.
Yeah.
Yeah, that's the first step. So I'm just going to write it like this, angle CBD. So angle CB and then D. Everybody sees that? Right? CBD. It's going to equal 90 minus 5, which equals 85 degrees. So I know in here, I got 85 degrees.
Get the angle like, for angle CBD, the one where D is, all you do is like take 40 plus 5 minus 180, which will get you that little angle, then you just minus it by 180 again to get the other angle.
So what are you trying to get? Yeah, well you have a little triangle here. I'm not sure how you got those numbers exactly, because
that wasn't.
so you can do 180 minus 40 minus 5 would give me this angle,
And then you take 180 minus.
and then you do 180 minus this and it'll give you that angle.
Yeah.
Is that what you said?
Yeah.
Okay.
I'm never good at this.
No, I just thought I'm verbally I have to. It'd be better if you pointed it out to me.
Yeah.
It just was. Okay. So here's a little triangle here, right? This little wee one here. And we know this angle and this angle, so we can find the other angle. Yep. Okay. So, what angle is that? ADB. It's going to equal 180 minus 40 minus 5, which equals 135. So I know right here, hard to draw it in there, that this is 135. And we know this is a straight line, so it's supplementary angle. I can just subtract and get. So now I can find CDB.